All right, here are warm-ups for 1.3 day 2. So we are continuing on from what we talked about yesterday. For our warm-ups, we need to simplify. So what we are going to do on these first two problems are just order of operations. On number 1, that means we need to combine like terms. So the only ones we can combine would be the 3 root 2 plus 5 root 2 because they have the same radical. That gives us 8 root 2 minus 2 root 3. Again, these cannot be combined with each other because they do not have the same radical. So that is our answer. On number 2, our order of operations tells us to start inside of parentheses. So that means I have 2 squared plus 3 squared. Next we do our exponents. So that means I have 4 plus 9, which is the square root of 13. That does not simplify because 13 is a prime number. So if we were able to simplify that radical, we would need to. Number 3, we have a right triangle with a missing side. We are missing the hypotenuse. We're going to use the formula from the Pythagorean theorem. A squared plus b squared equals c squared. A and b can kind of be interchanged. However, c is always the hypotenuse. So we have 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. When we add those, we get 100 equals c squared. To solve, we need to square root both sides. So c equals 10. That's our missing side. All right, let's move into notes. We are asked to find them. Well, we are not asked to find the midpoint. We are given the midpoint and one endpoint of a segment, and we are asked to find the other endpoint. So remember that we talked about our midpoint formula being x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So they told us that our midpoint this time is 3, 4. So we have to set up 2 equations in order to solve for our other endpoints. So we match up 3 equal to x1 plus x2 divided by 2. And then we also have 4 for the y-coordinate. So 4 equals y1 plus y2 divided by 2. All right, the other thing we need to do, though, is plug in the rest of the information we know. We were told that the x-coordinate of one endpoint was 1, so we're going to plug that in here. It does not matter which x you plug it into. Same thing will happen when we get to the y. For now, let's finish solving for x. We have to multiply both sides by 2. 6 equals 1 plus x. Subtract 1 from both sides, and we get that the x-coordinate is 5. So that is part of our answer for point C, 5, comma. Now we need to find the y-coordinate. So we're going to take the 6 from that endpoint and plug it in. 4 equals 6 plus y2 divided by 2. Again, multiply both sides by 2. 8 equals 6 plus y2. Subtract the 6 from both sides, and we get that y2 is equal to 2. So that is the y-coordinate of our other endpoint C. All right, let's move on. This next problem is just like the one before, so I want you to try it on your own. Go ahead and pause this if you're watching it back later. I'll show you the work and the answer in just a minute. All right, so here's our solution for example 2. We should have gotten point B at 9, 1. Okay, and I've shown my work here. If you did not get that answer, you can look through the work and see how we came up with it. All right, let's go on. This is not in the guided notes, but if we suppose that there is a right triangle located at the origin, and we're trying to find the length of the hypotenuse. Okay, so the length of the hypotenuse we've already talked about in the warm-ups. If we consider these A, B, and C, that we could use A squared plus B squared equals C squared. What's special if our right triangle is at the origin would be that this point, instead of being called x2, y2, we could just call it x2 comma 0 because it's on the x-axis. Same thing with the point up here. This could just be 0 comma y1 because it is on the y-axis. So those points then give us our lengths of A and B. A has a length of y1, whatever that value is there, and B has a length of x2, whatever that value is out here. So we would be able to plug those in. Y1 squared plus x2 squared equals C squared. Then to solve for C, we would just square root both sides. So C, or the length of the hypotenuse, is the square root of y1 squared plus x2 squared. Now this is, of course, special because it's centered at the origin, but this will help us start to see how our formula is going to work out later. So we're about to learn our distance formula, and this will end up looking pretty familiar. Okay, remember that distance is the same as length. So when we were asked to find the length of the hypotenuse, that's the distance between the points. So if A and B are our points with those coordinates, x1, y1, x2, y2, the distance or length, AB, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, this is the formula that we're going to use for distance and length. You can interchange where the 1s and 2s go. So if you wanted to start with x1 and then put x2, that's fine, as long as you also make sure y1 comes before y2. So as long as you're consistent, it will work out either way. So let's try using that formula. All right, they gave us R and T. R is at 3, 2. There's point R, and T is at negative 4, 3. There's T, and we'll go ahead and put our line between them. Okay. Now really we don't need the graph in order to use our formula, but we will talk about the graph here in just a minute. All right, so we have to start plugging these points in. So we have to start with an x value. So we can start with 3 minus negative 4 squared plus, then we do our y values. Because I started with 3, the 3 came from R, so I have to start with the 2 from R when I do my y's. So 2 minus 3 squared. We'll start simplifying by order of operations. 3 minus negative 4 is 7 squared, plus 2 minus 3 is negative 1 squared. I would recommend putting negatives in parentheses when you square them. Continue to simplify. 7 squared is 49. Plus negative 1 squared is 1. When we add them, we get the square root of 50, which can be simplified. If you like to use the factor tree to help you simplify, you can. I'll show that off to the side. So because we have the pair of 5s and a lonely 2, this is going to be 5 root 2 for the length of RT. So we didn't really use the graph at all when we did that. However, I'll show you one way that we could have used the graph is if we had turned this into a right triangle. So I dropped a vertical line and then drew in a horizontal line, turning this into a right triangle. Then we're able to count the lengths of the sides. Hopefully we can see that this side on the left has a length of 1. The side on the bottom has a length of 7. Okay, so then if we were using Pythagorean theorem, we would be taking 1 squared plus 7 squared equals c squared, and our work would end up looking exactly the same as it does down here. Okay, so distance formula is just another way of doing this. All right, let's practice this again. Now we've got G and H. They did not give us a graph. We don't need one. We'll just use the formula. X minus X, 5 minus negative 3 squared, plus Y minus Y squared, negative 1 minus 6. Make sure you're being consistent about what points you start with. 5 minus negative 3 is 8 squared, plus negative 1 minus 6 is negative 7 squared. That gives us 64 plus 49. The square root of 113. That cannot be simplified, so that is our answer. Make sure negatives are getting put in parentheses when you square them. If you end up thinking that this 49 is negative, then your answer would come out different and it would be incorrect. All right, let's move on. The endpoints of AB are given. The endpoints of CD are given. We are asked for the difference in the lengths. This time we will round our answer to the nearest hundredth. This question has a couple parts to it. The first part is to find the distance of both AB and CD. So we have to find two distances and then find their difference, meaning we subtract big minus small. All right, so for the distance of AB, we have 4 minus 1 squared plus 11 minus 15 squared. That leaves us with 3 squared plus negative 4 squared. So we have 9 plus 16. That's the square root of 25. So AB has a distance of 5. Let's switch to CD. Length of CD, the square root of 1 minus 2 squared plus negative 1 minus negative 3 squared. So we have negative 1 squared plus 2 squared. 1 plus 4, that gives us the square root of 5. Okay, so now that we have both of our lengths, we need to take the difference. So we take 5 minus the square root of 5. And this one says to round to the nearest hundredth. So that's 2 decimal places. So we should end up with approximately 2.76 as our difference. All right, there is our example 5. So that is the end of our notes for this section. Our homework is on the homework sheet handout, or here it is, page 20, 25 through 34, and 43 through 45.